All right, so we are in Precalculus. Today's date is Tuesday, October 15th, 2019. Make sure your name and date are on your paper. Yeah, we're talking about special right triangles. This is a purely review of geometry. Our objective today, who can read that for us? Teflon.
Use properties of 45, 45, 90, and 3, 30, 60, 90 triangles to find the side lengths of triangles.
GTH. Oh my gosh. Mr. Sindel. I cannot spell. Yeah. Andrea, can you just give everyone 70 XP? I hate it when I make typos like that. Yeah, so the origin of the 45, 45, 90 triangle, it comes from a square. I don't know if you guys remember that. Did I give these same notes in geometry, or are these kind of new for everyone? Cool, so these are kind of new. Geo, you can shut your laptop. You don't need that right now. So the 45, 45, 90 comes from a triangle, or sorry, comes from a square. This used to be a 90-degree angle, but if I bisect that, if I cut it in half, then it turns into a, shout it out, 45-degree angle. And Fiona doesn't need her AirPods in. I know you're trying to pretend that you're a boy, but exactly.
Oh, pause it. What?
Yeah, you can take those out. Okay, so it's a 45, 45,
What?
90.
You have to do that.
There it is. So that's where it comes from. Let's talk about the 45, 45, 90 triangle. I made new posters. They look nice. They're in the top area. I'm going to leave them up because why not? So the top poster tells you the general rule. The bottom poster tells you how to move around. I mean, I can't really see it from back here, and I have 20/20 vision, so you might have to stretch and walk around and look at the poster as you're working on your quiz or test. The main thing to know from a 45, 45, 90 triangle is this. If I have this length is x, this length with a quiet raised hand is what? James, I just said a quiet raised hand. With a quiet raised hand, what is this length, Fiona? X. I'll take your participation card, thank you. And what about this length right here? This length is Eva. X square root of 2. If you ever forget them, they are on the poster. Let's talk about how to move around on this triangle. If I want to move from a leg to the hypotenuse, what is the operation with a quiet raised hand as the default? Andrea? Andre, I guess. Multiply, so times by square root of 2. What about if I want to move from the hypotenuse to the leg? What is the operation that I do from the hypotenuse to the leg? Quiet raised hand again. How do I go from the hypotenuse to the leg? We'll go with Fiona again. You divide by the square root of 2. There it is. And just to make sure that we all know how to simplify radicals, I'll give you guys some review right now. What if I had something like, I don't know, 10, and I wanted to divide that by square root of 2? How would I turn this into something that doesn't have a square root in the denominator? How do I rationalize the denominator? Did we remember how to do this? You can shut this one out. Multiply by square root of 2 over square root of 2. There it is. So do that. If I multiply by the square root of 2 over square root of 2, the top is 10 square root of 2. I mean, you just squish them together. The bottom, though, is the square root of 2 quantity squared. So that's going to turn into quiet raised hand. Who can simplify this a little bit more for us? One more step, quiet raised hand. After I have 10 square root of 2 in the numerator and the square root of 2 squared in the denominator. Fiona's already done it twice. I need someone new or that's only done it once. How do I simplify that denominator? Nice and easy. Oh boy, no one knows how to do it aside from Fiona. Take a guess. You get XP for guessing. You get 50 XP, just as much as you would if you got it correct. Yeah, Chris. Good guess, but no, you still get your XP. What is the square root of 2 squared? Stego, tell us. Cross what out? You do, yeah. They cross out, and you're left with 2. Yeah, so our new fraction is 10 square root of 2 over 2. And what's 10 divided by 2? That can be simplified. Quiet raised hand. What is our final answer? Eva? It is indeed 5 square root of 2. Let me move this over so I have a little bit more room here. This is indeed 5 square root of 2. In fact, I should maybe move that down here. All right, so that's your review on how to rationalize the denominator, and I'll write that down too because it's nice to be able to talk about math. What we're doing here is called rationalize the denominator. If you forget how to rationalize the denominator, I know it's super, super small, but it is up there on a poster as well. I show you how to rationalize a denominator with square root of 2 and with square root of 3. Let's move on to the origin of the 30, 60, 90 triangle. So it comes from an equilateral triangle. Quiet raised hand. The interior of an equilateral triangle, all of the interior angles are what angle? Quiet raised hand. Quiet raised hand. Interior. This angle right here is this angle here, this angle here. They are all the same angle. They are, Andrea, good guess, but no. If I have 180 degrees and I divide that evenly amongst 3 angles, I get, Andrea? 60, yes. So all of them are 60 degrees. So this was 60 degrees, but again, I bisect the angle and it goes to 30 degrees. So that's where the origin of the 30, 60, 90 triangle comes from. Let's go ahead and label this. Let's go ahead and always assume that the shortest leg is x. If the shortest leg is x, because if I don't make the shortest leg x, all of this is really ugly fractions, then the hypotenuse is, Fiona? 2x, perfect. And the long leg is, Chris? It is indeed x squared root of 3. Thank you, Chris. So, good job, guys. We never go from the hypotenuse to the long leg. I mean, you could, but usually we just go on the bottom down here. So if I want to move from 2x to x, what is the operation that I do from 2x to x? Quiet raised hand. Teflon. Divide by 2. Perfect. What if I want to go from x to x squared root of 3? If I want to go from the short leg to the long leg, what is the operation that I do? Teflon again. Multiply by square root of 3. What if I want to do the opposites? What if I want to move from x squared root of 3 to x? How do I do the opposite of that? Come on, inverse operation, guys. You got the same number, inverse operation. Fiona? Divide by square root of 3. What if I want to move from x to 2x? Instead of divide by 2, I'm going to do the inverse operation, and I'm going to do what? James? James, come on. Inverse operation of divide by 2, go. Inverse operation of divide is by, there it is. Thank you, Teflon. All right. So now you know how to move around a 30, 60, 90 triangle. You know how to move around a 45, 45, 90 triangle. If you don't have this stuff down today, tomorrow's lesson is going to be excruciatingly difficult. All right, so let's do example number 1. I need to find the length of x. Who can do that for us? I need to somehow move from a short leg, or just from a leg, to the hypotenuse. So tell me what my operation is and what my answer is. Fiona. Perfect, which means my answer is 5 root 2. It is that easy. Thank you. I'll let you catch your breath. I'll let you analyze. I'll make sure the pacing isn't too fast here. And then we're going on to example number 2. Now I need to go from the hypotenuse to the short leg. How do I do that? Quiet raised hand. Andrea. Divide by 2 to get 4. The answer is 4. Easy peasy lemon squeezy. And now I have some hard problems. Those I consider easy problems. These I would consider them medium problems. They're not that hard. Everything with special right triangles can't be that hard. They can only get up to medium difficulty, in my opinion. Once you see them once, they come pretty easy. How am I going to get from the hypotenuse to the leg on a 45, 45, 90 triangle? Teflon.
You divide by square root of 2.
Divide by square root of 2. Eva, can you help us do that? If I have 6 divided by square root of 2, do you think that you might be able to help us simplify to rationalize the denominator? And I know that it takes some room, so I'm going to move over here to the left a little bit more. Go for it, Eva. There it is. Ooh, careful. Just square root of 2 squared, right?
Yeah.
Square root of 2 quantity d squared. Next step. Over 2 because those cancel out, which reduces to 3 square root of 2. Thank you, Eva. All right, and example 4 is the hardest type of problem that I can ever ask because I have to make you do multiple operations with dividing by radicals, lots and lots of math. So a lot of people might be tempted to go from 9 straight to x, and you can do that if you know the trick that I haven't taught you, which is to divide by square root of 3 and to multiply by 2 at the same time, which is the equivalent of going here first to the short leg and then to the hypotenuse. So I think the easiest way for us is to stay consistent. How do I go from the long leg to the short leg? What is the operation? I just need one quiet raised hand. Easy operation. Just look at your notes. What is the operation to go from the long leg to the short leg? Stego. There it is. Divide by square root of 3. So now I need to come up to the top and do some scratch work. I need to say 9 divided by the square root of 3. Quiet raised hand. Who can rationalize the denominator here? Fiona. Perfect. I love skipping steps when you know what you're doing. All right, so that means that this bottom leg, this short leg, as Fiona said, is 3 radical 3. By the way, there are tons and tons of shortcuts that I have not mentioned, like, oh, if I see that this is divisible by 3, then divide it by 3 and add a square root of 3. Or if I see that this is divisible by 2, divide it by 2 and then add a square root of 2. I mean, there are a lot of different shortcuts you can make. But finally, my operation to get from the short leg to the hypotenuse. What is just the operation? I'm looking for the operation. Fiona again. Multiply by 2. And someone tell me what my answer is. Quiet raised hand. What is my final answer for my last example? Final answer. Chris, go for it. You got this, Chris. Multiply by 2. The 2 multiplies by this number, not the root. It is indeed 6 square root of 3. Cool. Give me a fist of 5 on special right triangles. How well do you think that you can move around using these operations and find all of these different side lengths? I'm seeing a 5, a 5. Is that a 4? 3 is a 4. 4.5. Stego's at a 4. James, what are you at? James is at a 4. Teflon? 5. Okay, so those are pretty high scores. So the homework should be a breeze tonight then. That concludes the notes. Go ahead and begin on the homework.